Good day, everyone. We are Group 3. I am Vergara, together with my group mates Aoyama, Kane, Esteves, Limosnero, Mendoza, and Moreno. Our topic is entropy. For my part, I'll be discussing the objectives of our presentation. First, to define what entropy is. Second, to provide a real life example that demonstrates the concept of entropy. Third, to predict the spontaneity of a process based on entropy. And lastly, to highlight what we have learned about the topic.
Now that you know our objective, let's start with our bell work to get an idea of what you already know about today's topic. So, for today's bell work, you have a random set of cards with different colors and numbers. In order to win, you must match the cards drawn through symbols and color until you have none left. Is this considered a low to high entropy or a high to low entropy? This question will be answered after a discussion of the concept of entropy.
So now let us define what is entropy. Entropy is the amount of unusable energy of a system for every process as it approaches its end state. When entropy increases, it means the system becomes more disordered and its energy become less useful for doing work. The amount of unusable energy in the definition is what we refer to as entropy. It states that it is the measure of how much energy in a system becomes unusable as a process occurs and moves towards its final state, and that in every process, such as melting ice, some energy is used to do the useful work while some becomes spread out or wasted, making it unavailable for further use. When entropy increases, it means the energy has become more disorganized and less capable of doing work. In simple terms, entropy shows how energy gradually becomes less useful as it spreads out during natural processes. According to the second law of thermodynamics, anything in this world will be exhausted and will reach its end eventually. So, the second law of thermodynamics states that in every natural process, entropy always increases. This means energy naturally spreads out and becomes less useful over time. As heat from hot to cold, some energy becomes unusable. Applying this to the concept of the heat of the universe, scientists believe the universe is moving towards a state where all energy is evenly distributed. Eventually, this will lead to the heat death of the universe when no temperature differences remains and all processes stop because entropy has reached its maximum.
An example of entropy is a clean room becoming messy. This shows an increase in disorder, meaning higher entropy compared to a clean room with organization. To reverse the disordered state of the room, energy must be inputted to clean it. Imagine your room is clean with everything in its place and well organized. That is an example of low disorder or low entropy. But over time, clothes pile up and objects scatter, the disorder increases, and so does the entropy. To make the room clean again, you have to put in effort to organize it, which means adding energy to bring the system back to order. Another example is melting ice. Since ice is solid, its molecules are shaped in an organized and structured way. When ice melts into a liquid, its molecules have a given freedom to move around, which increases the disorder and entropy. In its solid form, ice has water molecules that are neatly arranged in a fixed and structured pattern. This is why ice keeps its shape. But when heat is added, the molecules start to vibrate faster and break free from their positions. As the ice melts into liquid water, the molecules gain the freedom to move around more easily. This increases their disorder, or what scientists call entropy. So, melting ice isn't just a state change, it is a transformation from order to disorder, showcasing entropy.
Predict the spontaneity of a process based on entropy. We can predict the spontaneity of a process by examining the changes in entropy that occur within both the system and its surroundings. Entropy S is a measure of the disorder, randomness, or energy dispersal in a system. It indicates how energy and matter are distributed among the possible microscopic states available to the particles. A process is spontaneous when it results in an overall increase in entropy, meaning greater molecular freedom and randomness. To predict spontaneity based on entropy, We examine how the level of disorder or randomness changes during a process. Entropy, represented by the symbol S, describes how energy and matter are distributed within a system. The guiding principle is that a process will be spontaneous if it leads to an increase in the total entropy of the universe, which includes both the system and its surroundings. This means that nature naturally tends towards states of greater disorder and energy dispersal.
When entropy decreases, the system becomes more ordered, making the process non-spontaneous and requires external energy input. By analyzing how this order changes, we can determine whether the entropy change of the universe occurs naturally or needs external energy to take place. When the particles within a system become more dispersed or gain greater freedom of movement, such as when ice melts or a gas expands, entropy increases. This means that the energy is spread out and disordered, allowing it to be distributed in many possible ways, and the process occurs spontaneously or naturally. These changes do not require continuous energy because they align with nature's tendency toward randomness. On the other hand, if a process results in more order, such as when water freezes or gas molecules are compressed, entropy decreases. In this case, energy becomes organized and localized, leaving fewer possible arrangements for the particles, making the process non spontaneous unless external energy is applied.
Now, going back to our bell work, the answer for this would actually be high to low entropy. This is because in the first half of the game, you have different colors and numbers of cards, meaning it is more disorganized. While in the second half of the game, you will have to be drawing the same color and same symbol cards until you have none left, meaning this is more organized and it is considered low entropy. So that is the answer for our bell work for today.
Here's our takeaway about entropy. Entropy helps determine if a process will happen spontaneously or if it requires energy. Higher entropy means particles are more spread out and energy is more evenly dispersed. Entropy guides scientists in designing efficient systems and predicting reaction behavior. Entropy explains the natural tendency of systems to move toward disorder and energy balance. Grasping entropy is crucial because it explains the reasons behind reactions and processes. It is widely used in science and engineering to predict how reactions will behave and to enhance energy efficiency. In summary, we can predict spontaneity by observing whether a process increases or decreases disorder. If the total entropy of the universe increases, the process is spontaneous. If it decreases, the process is non spontaneous. Entropy, therefore, acts as a guide that allows us to understand the natural direction of physical and chemical changes, always toward greater randomness and stability.
And that concludes our presentation. Thank you for listening, and we hope you've gained a better understanding of what entropy is. Thank you.